Hi everyone, welcome back to a new video. In this video, we are going to talk about empty struct. We'll talk about what exactly an empty struct is, how we can create that, how we can use that. We will write a few Go programs where we will see different applications of empty struct. So let's get started. Let's first start with what an empty struct is. Empty struct, as the name suggests, is nothing but an empty struct, which means it has no fields, it has no data, and most importantly, it takes 0 bytes in memory, which is very important for us in cases where we do not care about the value, but we care about existence of something. I'll elaborate this thing further by the help of examples. Let me first show you how an empty struct looks like. This is how we can create an empty struct. In fact, if I go ahead and show you the size of the struct, this didn't get imported. Let's run this. And you can see the size is 0. Now, why should we care about an empty struct which has no field, which has no data? We only care about empty struct in places where we care about existence of something rather than the value of something. Let me show you what I mean by that. Let's go ahead and create a set of, let us say, fruits. We will create a map, and the usual way we would want to do it without an empty struct would be to have a boolean value. So let's say apple true, banana true. Let's also say mango true. Now, if you want to check existence of a particular fruit, we can do that by, for example, fruit is apple, and we want to check its existence. We'll say exists fruit set fruit. Now we can say if exists this looks fine. Let's run it. Before that, let's remove this. And we can see that it says apple exists in the set. Now, if you look at this code, we can see there is no use case of this true value. Actually, technically here we can say there is some use case of true because I have written it here, which is basically the value. But let's do it this way. Now it should be clear. There is literally no use of this true value over here. You can call this false as well. And if I run it, it should still come the same. If you want me to do false for apple, it should still be the same. Why? Because we are not even checking the value. We are only checking the exists part, or some people call it okay. So we are only doing a lookup in the map. We don't really care about the value. Now this code is good, but it can be improved. Let's do it this way. Let me just copy this thing again and comment it out. Let's create the set again. This time, or the map, this time, we are not going to give it true or false. We are just going to give it an empty struct. And here from bool, we will change it to empty struct. Looks good. And now when we run it, the result should be the same. The only difference here is these empty struct values takes 0 bytes of memory, while the other Boolean values would take at least 1 byte per value. And as the map keeps on growing, the memory these Boolean are taking will also keep on increasing. That is one really good advantage of using empty structs. And I think now this should explain the statement I said, that we will use empty structs where we do not care about the value of something, we care about the existence of something. Here, we didn't really care about the value of these values, we only cared about the existence of these keys. So in this case, we can use the empty structs. Let me show you another example of this. Let's create a new package. Let's call it channels. Let's create another main.go. And here, I just want to create a very basic channel, and then I want to pass something to that channel, and I want to make sure that the go routine where I'm entering something to channel should be completed, and only then we should move ahead. So how can I write that? Let's say we'll write a done channel, which will be either int or it could be bool, whatever. And then we will write a go routine let's make it sleep for a second. Before that, let's put a print statement starting routine, and after a second we can say ending go routine, and at this point we can put some value in the done channel. Let's say true, and we will only go after this once we have received something in done channel. After that we can say let's say completed, and firstly we need to call this, and then I also want to add a statement here saying received the value, we can move ahead. Yeah, this looks good. It's better now. Let's run this. And we can see that, oh, actually, yeah, makes sense. They should run first. So let's just remove this because this is not making any sense. So first, the execution starts, go routine is created, this is printed, and then we cannot go out, like this is running concurrently, but we cannot go beyond this done statement because it will block the execution of this main function unless something is received in this particular channel. So by that time, this print statement is executed. It is sleeping for 1 second. This print statement is again executed. So it should be starting go routine, then ending go routine, ending go routine. And after that, when a value comes in done, that means the blocking statement is removed, and then we can say completed. Now here, you can again notice that this boolean has no job. This true has no job. We can also call it false, and it doesn't change anything. It will do the same exact thing. It will follow the same behavior. In fact, we can change this to int, and we can give any value over here, 100. And it will still do the same thing. So in such cases, why would we want to waste our memory? We can simply use empty struct over here. And then we can pass this empty value. And this should still work the same. It is still doing the same thing. The only difference is now we don't have to worry about memory because this didn't take any bytes in memory. We don't have to worry about allocation. So this is much more faster. And we don't have to worry about garbage collection and all because we are not taking any memory itself. There is no memory allocation happening, which makes this option much better than using a bool or using a int in cases where, like I said, the existence of something is important, not the value. In this case also, the existence of this empty value is important and this empty struct is important rather than the actual value of it. And you will see the applications of empty struct in similar places only. Mostly we use it with, like we showed here, in creating sets, and we also use it with synchronizing go routines by the help of channels. And then it can also be used for other complex tasks, but the idea remains the same, that we use empty struct when we care about the existence and not the value.